of collections into a larger collection. These sets can be homogeneous or the same or heterogeneous and different. So we have some examples. Henry has 2 balloons and Billy has 3 balloons. How many balloons do they have together? And that's a homogeneous set. The sets are the same, both balloons. And then Janessa has 1 apple and Gage has 6 grapes for snack. How many pieces of fruit do the kids have?
2 plus 1 equals 3. 3 plus 1 equals 4.
Important skills to develop for addition are effective strategies to combine sets, use addition algorithms, recognize and use properties of addition, and quick recall.
6 plus 1 equals 7.
Scope and sequence for addition is, in kindergarten you start with simple joining and separating activities. First grade is new strategies like using the number line or length-based models. In second grade they should be getting quick recall of math facts and the arithmetic representations and beginning into multi-digit. In third through 5th grades, the addition is embedded within other content.
Add 'em up, add 'em up. Add 'em up, add 'em up. Add 'em up, add 'em up.
Strategy for teaching addition, use collaborative small groups for problem solving, give them opportunities to communicate their thinking, provide some direct instruction to clarify misconceptions and different concepts, and provide them with multiple ways of representing the same concept, and most importantly, use lots of manipulatives.
1 plus 1.
In order to engage students in the content of addition, it is important to use a variety of manipulatives such as candy, animals, trucks, or anything that appeals to their interest. This is also important because it provides the addition in multiple settings and multiple concepts so that students will be able to carry their knowledge to other settings. It's important that addition be hands-on and that the kids have something that they can physically manipulate, and it's important to give students a purpose and relate the content to their real world.
Plus 1 equals 7. 7 plus 1 equals...
A lot of knowledge a teacher should have before teaching addition. Some of this includes knowledge about common misconceptions and how to avoid or correct them. A teacher should know that addition is a building block for future operations. Teachers should also know how to use different algorithms and representations of a problem. So if we have 4 plus 4 equals 8 vertically, 4 plus 4 equals 8 in the horizontal form, and a set of 4 and a set of 4 that is the same as a set of 8. The teacher also needs to know that the students need to have a strong hold on place value before they can understand how to do multi-digit problems.
Add 'em up, add 'em up. Add 'em up, add 'em up.
Potential pitfalls when representing addition are that students misunderstand the meaning of the equal sign. It's important to not introduce the equal sign too early to avoid students developing this misconception. An alternative way is to introduce with a parts to whole model or a separation model with the equal sign being a line that separates the 2 parts. So you have 2 plus 3 is equal to or the same as 5. It's important to watch your language and not introduce the equal sign or the term equal too early so that students do not develop this misconception. Another common misconception that occurs with addition is where to put the numbers in a vertical representation. A way to try to combat this is to make sure that students have a strong understanding of place value prior to introducing this representation, as well as introducing it with manipulatives and images so that kids become familiar with the top plus middle equals bottom.
9 plus 1 equals 10.
Using the parts to whole model shows the students the whole versus each part. So in this part you have 4, in this part you have 3, and as a whole you have 7. So after introducing that, and once your students have a solid grasp on the parts to whole concept, you can introduce the algorithm that 4 plus 3 equals 7.
To teach beginning addition is to use the number line or the counting on procedure. Using this process, you have the students find the first number in the arithmetic representation on their number line. So for us it's 2, so we go 0, 1, 2, and then they're going to count on 5 spaces on the number line and see where their answer ends up. 1, 2, 3, for 5. 2 plus 5 is the same as 7.
For teaching addition is to introduce students to the vertical model with pictures or manipulatives. It's important for them to see that we can use manipulatives vertically and horizontally because they will eventually have to use algorithms vertically and horizontally. So here we have 4 plus 5 equals 9.
7 plus 1 equals 8.
The most important thing when teaching addition and the algorithm for addition to young students is to start with the more simplistic and concrete, such as manipulatives or something that they can get their hands on, and move to the more abstract and complex, such as the written algorithms, both horizontally and vertically.
Add 'em up, add 'em up. Add 'em up, add 'em up. All you kids in the classroom, please add 'em up.